Hello, kids! Today we are going to learn about the Earth's structure. So, kids, there are 4 layers of the Earth. The first layer is called the crust. The crust has 2 parts. The first part is called upper crust. The second part is lower crust. The second layer is called the mantle, and the third layer is called the core. Now, core has 2 parts, outer core and inner core.
The Earth's crust is the planet's thinnest, outermost solid layer, accounting for less than 1% of its total volume. It exists in 2 distinct forms: the thick, less dense continental crust made largely of granite, and the thin, dense oceanic crust composed mainly of volcanic basalt. Together with the rigid upper mantle, this rocky shell is broken into dynamic tectonic plates that float on the semi-fluid mantle below. Driven by internal heat, the continuous movement, collision, and separation of these plates are directly responsible for creating mountains, triggering earthquakes, and fueling volcanic activity across the globe.
The Earth's mantle is the thick middle layer of our planet, located just beneath the hard outer crust. It is incredibly huge, making up most of the Earth's total volume. The mantle is made of very hot, heavy rock, rich in iron and magnesium. Because it is so hot, the rock acts like a thick, gooey paste or warm plastic that moves very, very slowly. This slow, churning movement pushes and pulls the tectonic plates on the Earth's surface, which is what causes earthquakes and forms volcanoes.
The Earth's core is divided into 2 parts, a liquid outer core and a solid inner core. The outer core is a super-hot, 2,300 km thick layer of liquid iron and nickel that constantly churns, creating the electric currents that form Earth's protective magnetic field. Beneath it lies the inner core, a solid metal ball about 1,220 km thick that is as hot as the surface of the Sun. Even though it is scorching hot, the inner core stays completely solid because the immense weight of the rest of the planet squeezes it together with incredible pressure. The Gutenberg discontinuity is the distinct interior boundary located approximately 2,900 kilometers, 1,800 miles, beneath the Earth's surface that separates the solid silicate lower mantle from the liquid iron nickel outer core. Discovered by seismologist Benno Gutenberg in 1914, this boundary is identified by a dramatic change in seismic wave behavior. Primary waves, P waves, drop sharply in velocity, while secondary waves, S waves, disappear completely because they cannot travel through liquid. This transition zone, which also marks an intense increase in density and temperature, plays a critical role in Earth's thermal convection and the generation of its magnetic field. The Mohorovicic discontinuity, commonly known as the MOHO, is the boundary layer that separates the Earth's relatively light crust from the denser underlying mantle. Discovered in 1909 by Croatian seismologist Andrija Mohorovicic, this seismic boundary marks a sharp change in rock composition, transitioning from lower-density rocks like granite and basalt to high-density peridotite. Because seismic waves travel faster through denser material, their velocity increases abruptly as they pass through the MOHO, allowing scientists to map its depth. The MOHO is not uniform, it sits roughly 8 kilometers deep beneath the ocean floors, averages 32 kilometers deep under the continents, and plunges up to 70 kilometers beneath major mountain ranges.